Hi my friend, you're warm welcome for today's session. Today I'm going to continue with our chemistry subject, particularly with our topic of electrolysis. And for today's session, I am going to deal with the weak electrolytes and strong electrolytes. First of all, let us know the meaning of strong electrolytes. What are strong electrolytes? What does it mean by the term strong electrolytes? Strong electrolytes are the electrolytes which dissociate completely into the ions when in solution form or in molten state. A good example of strong electrolytes are like table salt, sodium chloride. Also we have different mineral acids. All of these are strong electrolytes. Let us take a look for the association of our table salt, sodium chloride, and one of the mineral acids like hydrochloric acid. For example, let us start talking about strong electrolytes. Electrolytes. Now, for example, when we talk, when you consider a look on HCl, hydrochloric acid, this is one of the mineral acids. When this dissociates, it dissociates completely into its free ions, which are hydrogen proton and chloride ion. Now we may see, how do you know that? By looking at this equation that it is a strong electrolyte dissociation. This shows that it is a strong electrolyte because we have used a single full arrow, as you may see. And now also we can see another example of strong electrolyte is like maybe sodium chloride, a table salt. When this dissociates, it dissociates completely into its free ions. Sodium ion and chloride ion, as you may see. Now, these are some of the examples of strong electrolyte dissociation. So all of these, they dissociate completely into their respective ions. Let us now consider the meaning of weak electrolytes. What are weak electrolytes? Simply we say weak electrolytes are the electrolytes which do not dissociate completely or dissociate partially. They dissociate partially when in molten state or solution form. A good example of weak electrolytes are like ammonium chloride, also, and other many organic acids. Organic acids are weak electrolytes. Now let us see. Now I have told you that when we are speaking about weak electrolytes, the examples are like ammonium chloride, So as ammonium chloride is one of the weak electrolytes, it means that it dissociates partially into its free ions. So is the partial dissociation is shown by using half double R, as you see here. Now it becomes ammonium ion, and chloride ion, as you may see. So this equation shows partial dissociation of ammonium chloride. So half double arrow indicates that the dissociation which is concerned involves the weak electrolyte. Also, we have different examples of organic acids, and one of them is like ethanoic acid. Also, ethanoic acid dissociate in the same way as ammonium chloride, as you may see here. Now, when this dissociates, you are going to get these ions. Now, and the hydrogen proton. Now you may see these last two examples shows the dissociation of weak electrolyte. How can you differentiate them with the first examples? They are different because in the last two examples, on the section of weak electrolyte, I have used the half double arrow to mean that the dissociation is partial. It means that it can the dissociation can go in either direction, either forward or backward. As it is partial, it is not as strong. It does not involve the dissociation of a particular electron completely. But in the first two examples, I have used a single full arrow in each equation to mean that the dissociation is complete. A particular electron dissociates completely into its free ions. Now, after these examples and the definitions I have given to you, I hope you have understood well the lesson, and I take this chance to thank you for attending today's session. I wish you a nice moment. Thank you for attending today's session. Have a nice moment.